Titan, a mysterious world unlike any other in the solar system, is one of the most intriguing moons that we know of. Welcome to the Daily Galactic. Today we're talking about the largest moon of Saturn, Titan, and what lies behind its dense atmosphere and the possibilities of life on this alien world. This cloudy moon is the second largest moon in the solar system after Jupiter's giant Ganymede. In fact, it's larger than the smallest planet Mercury, but only 40% as massive. When side by side, Titan can appear to look larger than Ganymede, but this is because of its extensive atmosphere that reaches far out into space, but more about its atmosphere later. Titan orbits Saturn once every 15 days and 22 hours, and like the Earth's moon and many others in the solar system, its rotational period is the same as its orbital period. This means it's tidally locked, so from the surface of Saturn you see the same face of the moon all the time. The smaller regular moon Hyperion is also in a 3 to 4 orbital resonance with Titan, meaning that Titan completes 3 orbits in the time it takes Hyperion to orbit 4 times. The primary moons of both Jupiter and Saturn were believed to have been formed through a process called co-accretion. It's a similar process to how the planets formed in the early solar system. As Saturn was formed, it was surrounded by disks of rock, metal and gas that gradually combined under the force of gravity to create their moons. Titan, however, has a high orbital eccentricity that isn't explained fully by this idea. A proposed model to combat this suggests that early in Saturn's evolution, it featured different moons that were heavily bombarded by multiple impacts that eventually formed Titan. One of Titan's incredibly unique features is its thick and hazy atmosphere. It's the only moon in the whole solar system that has one. It's composed primarily of 97% hydrogen and is considered to be a superrotator just like Venus. This means that its atmosphere rotates quicker than the surface. It's also much denser than the Earth's, making the atmospheric pressure on Titan's surface to be about 1.45 times that of Earth's. Within the atmosphere are a wide variety of trace hydrocarbons such as ethane, carbon dioxide and carbon monoxide. Usually, an atmosphere with as much methane in it as Titan's would have depleted its methane source within 50 million years. But the fact that it hasn't showed that Titan must have a reservoir of methane to be able to replenish it frequently. This most likely comes from eruptions from cryovolcanoes, but organic life as a source hasn't been ruled out yet. The opaque haze is so thick and dense that the clouds block almost all visible light from the sun from penetrating it. This makes observing the surface of Titan in visible light very difficult, and it wasn't until the Cassini-Huygens spacecraft arrived at the Saturn system in 2004 that we were able to see the surface for the first time. Titan's surface is one of its other super unique features. Apart from Earth, it's the only known body in the solar system to have liquid on its surface. Both Hubble and Cassini used infrared imaging to be able to peer through the thick haze and see the alien world that lies beneath and discover its lakes and valleys. It has a diverse geology of rough and smooth terrain, with few impact craters and small mountains that reach to only about 1 kilometer in height. There are bright areas like Xanadu, a large reflective region about the size of Australia. It features criss-cross patterns in its surface that may represent tectonic activity, indicating that this part of the moon is rather young. Alternatively, these patterns may be liquid form channels that have been cut through by stream systems. Titan has large bodies of liquid like its second largest sea, Legia Mare. The seas and lakes are composed of almost pure methane in liquid form and not water, however. The first lake to be confirmed was Ontario Lacus. It's found near the southern pole of Titan and is about 20% smaller than its namesake on Earth, Lake Ontario. The majority of lakes found on Titan are near its poles, but only cover a small percentage of the moon, making it much drier than the Earth. This beautiful image of the moon shows a specular reflection off of a giant lake that's now known as Jinpo Lacus. From early radar measurements, it was shown to be extremely shallow, reaching a maximum depth of 3 to 7 meters. In contrast, La Guillaume was mapped to depths exceeding 8 meters, which was the maximum discernible measurement of the radar equipment at the time. Later measurements of Titan's 3 methane seas showed astonishing depths of more than 200 meters. La Guillaume, the second largest sea, contains enough liquid to fill 3 Lake Michigans. On Earth, liquid oceans pave the way for life to exist, and whether it's the same for Titan's liquid oceans is a much debated topic in the scientific community. Its thick atmosphere is rich in hydrocarbons, organic compounds, and is chemically active. All 3 are parts of the building blocks for life. Hidden under its icy shell is also believed to be a layer of liquid water, and with the lakes of methane and ethane, some scientists theorize that these mixes may provide the prebiotic chemistry for living cells that differ to those on Earth. In June of 2010, the Cassini-Huygens mission reported anomalies in the atmosphere near the surface that are potentially consistent with the presence of methane-producing organisms. Although don't get too excited, as it could just as easily be non-living meteorological or chemical processes. Sadly, the Cassini mission wasn't equipped with the right equipment to continue its search through the complex organic compounds. Amazingly though, the Cassini-Huygens mission completed a remarkable feat of human engineering and actually landed an atmospheric probe onto the surface of Titan in 2005. With this amazing image taken from the surface, it was revealed that many of the features had been formed by fluid, like these rocks that have been eroded into smoother spherical shapes like pebbles on Earth. These pebbles are actually made of rock-solid water ice and are much smaller than they look. The left-hand rock to the centre is 15 centimeters across, and the one in the centre is only 4 centimeters across. We have lots more to look forward to in missions to Titan. Launching in 2027 and arriving at Titan in December of 2034 is the Dragonfly mission. Developed by the Johns Hopkins Applied Physics Laboratory, it will launch a large drone that will fly around the intriguing moon and study how far prebiotic chemistry has progressed. Thank you so much for watching all the way to the end. The support on my Instagram and this channel have been incredible lately, so thank you for helping me grow and keep creating content about our amazing cosmos for you. If you have enjoyed, please be sure to leave a like and subscribe to the channel for more videos just like this. If you have any questions, leave them in the comments below and I'll be sure to reply. See you soon.